All right, this one says, give the reasons for each step. So in the first of all, you have your diagram, right? And then you've got given angle 1 is congruent to angle 5. Prove angle 1 is supplementary to angle 4. So our first reason is what? Given. That's the information that's given to you, okay? Which either comes from a statement that says given, or it could come from the picture as well. Then 2 is what? We're restating it by going from the congruence to equal. Definition of congruence.
So how is that the definition of congruence?
Because congruence means equal. Right? Like if I just said something was congruent to something else, how do you know what that means? Because you know that the definition of congruence means they are the same object, right? Same shape and same size or same value. So if you're going from congruent to equal or equal to congruent, either direction, that's the definition of congruence. Jonathan, you know the second one? Or the third one?
No, that's if it went the other way around from equal.
It would also be the definition. Yep. 3 says angle 4 and angle 5 are a linear pair. Sophia? Linear pair postulate, which comes from my diagram.
I put definition. Would I get that wrong?
Yes. Okay. Actually, no.
So what's the
Definition of linear pair. Sorry, you're right. Because, can you stop yelling at me and let me teach for a second? If that's okay, I'll do my job. Okay? So if you look at the diagram, 4 and 5 are next to each other and form a line, right? That means they are linear pairs, and that is the definition of a linear pair. When we go to the next step and we now say that they are supplementary, that is...
Plus your postulate.
What did you just say? That is...
No.
Linear pair postulate.
That's linear pair postulate. So if we're going from that they are a linear pair so that they are supplementary, that's linear pair postulate. Now we're going from supplementary to that they add up to 180, which is what? Yep.
When it ever says definition, would it just be stuff that's just obvious?
Well, but it's obvious because you know what that word means, right? If you didn't know what the word supplementary was, you wouldn't know it was 180. So it's because you know the definition of supplementary that gets you to the 180.
So is it like something that you already know? Like
If it's based on a definition. Yeah. But again, like same thing, like if you walked in here 2 years ago and I said that's a linear pair, and you'd be like, I don't know what a linear pair is. Now you know the definition of a linear pair, that there are two angles that form that line. So you use that because you know the definition of linear pair. So anything that's like that, if we're actually using the definition to describe it, that's when we would use that. Sophia?
Can I do it?
Yes.
Well, I think I got it wrong. It's a substitution.
It is substitution. So from 5 to 6, you took 5 and replaced it with what it equals, which up here we said was angle 1, and that's substitution. And then 7 says angle 1 is supplementary to angle 4, and that is?
definition of wait
Yeah, you're on the right track. Good.
again.
Because we went from that they are equal to 180 to that they are supplementary. That is based on the definition of supplementary.
I can't believe I got that right. I'm so
All right. This one says, again, just write a proof, and this is completely open. So based on what they give you in the beginning, they're saying angle 2 equals angle 3. So I mark it so that I have that visual, okay? And that's where I'm going to start. Number 1, angle 2 equals angle 3. And the reason there? Given. Now I eventually, hang on just a second. I eventually want to get that 3 links with 6, okay? So that's my ending goal. Give me what you got, Sophia.
Okay, I put 2 and 6 are vertical angles.
Okay. Angle 2 and angle 6 are vertical angles. And how do you know that?
Vertical angle.
Good. Okay, then what?
And then I just, oh shoot, I missed.
Okay. Mars.
For the second one, can't you just say that 2 and 6 are congruent and then say definition of vertical angle?
You can't say they're congruent until you state that they're vertical angles. Now I can say they're congruent. Yep. Now angle 2 is equal to angle 6, and that's the vertical angles theorem. Says vertical angles are congruent.
How come it's not definition of?
Why are you yelling at me?
How come it's not definition of?
Why are you showing your words?
What?
Just say why are you?
Keep going, please. Ask your question. Ask your question. Why are they not what?
Why is it a definition of something? Of vertical angles.
Well, that we use for 2, right? We identify them as vertical angles in 2, but now we're saying that they're equal. And the theorem is what says vertical angles are equal.
I thought it has to be equal to each other for it to be definition of.
No. The theorem of vertical angles says 2 vertical angles are equal to each other. So it's only if you are using the definition that you use the words definition. So if you're saying supplementary equals 180, that's a definition. Don't bang your iPad on the desk like a child. If you're saying that they are a linear pair from the picture, that's definition of a linear pair. But vertical angles, we know that they are congruent not from the definition of vertical angles. We know they are congruent from the theorem. So you have to use the theorem.
What does that stand for?
Vertical angles theorem. Mars.
I have the next one.
Which is?
3, angle 3 equals angle 6.
And how do you know that?
Substitute.
Oh, you were so close.
Transitive.
Transitive.
What? Those are so
Because we're literally saying 2 objects, which in this case are angles, equal the same angle. So we're
if it's more than 2, then it's substitution.
more than 2 substitution or their values involved.
Like 180 or.
Yeah. You can use substitution. But if you're physically talking about 2 angles equaling the same angle, so you link them together, that's transitive. I see you. 2 segments equaling the same segment, so you link them together, that's transitive. We should be getting a little bit more comfortable with proofs. The test is going to have the algebraic one where it's completely open. You're solving your steps and you're explaining your steps. And then there's a geometric one, but it is partially filled in. We are going to get to the point probably next chapter in which your test does have a completely blank proof and you're going to have to fill it in. But we're going to baby step our way in that direction. Yes?
Wait, so there's going to be a point where we're doing proofs and we're not going to have any
Like this.
That we're going to have to remember every postulate?
Yep. Welcome to geometry.
Yay.
Yep. It's compounding information. Yep.
And then after this, I'm just never gonna do it again.
All right, so I'm going to add a little bit to it, and we're going to highlight some stuff instead of like creating a whole separate note. If you want to write directly on your review, I think it's probably good because this is separated out by section, okay? So 2-1, 2-2, and 2-3 is what was on your quiz, okay, which I'll go over once I'm done with the review. 2-1 was where we had a lot of definitions about logic. So this was what is a hypothesis, which is what follows the if, right? What is the conclusion? What follows the then? The if-then form is exactly that, something that's put in, like, for example, on this one, if it is a leap year, then it's a year with 366 days, okay? And then the converse, we switch the order. So if this was P to Q, then the converse, we switch the order. So it would be Q to P, switching the order. The inverse, we negate, which means state the opposite. I added that on there too because that's not on there. State the opposite. So the inverse, we negate the if and we negate the then. So if it is not a leap year, then it is not a year with 366 days. The contrapositive, we flip the order and negate it. So it's not Q and not P.
I don't have the review.
Let it refresh because all right, so, and then biconditional is the one that has the words if and only if, right? So this is an example in which the original statement is true and its converse is true, so we can make a biconditional out of it. It is a leap year if and only if it's a year with 366 days, which means it's true both directions, okay? If you're asked to negate like you were on the quiz, you just state the opposite of what it was. What was yours? Something with the roads being icy, right? The roads are not icy, so then the roads are icy or other way around, okay? The if-then form, so numbers 1 through 4 are going to have you go through that. Write that statement in an if-then form, and then write the inverse, the converse, and the contrapositive, and then the biconditional statement. There are 4 practice ones there. If you do great on 2, maybe you don't need to do all 4, okay? This is up to you what you need to do. You're not going to turn this in, okay? You need to do as much as you need to do to be ready.
I should focus on the last 3 chapters.
Okay. Just don't forget stuff from the beginning, okay? 2.2 was inductive and deductive reasoning, okay? Remember, deductive is based on the facts and definitions. Inductive is based on patterns. Yes.
So like the deductive and inductive questions are really easy. Is it going to be like on the test?
They should be easy.
They're going to be the same as they were.
They are not going to be the same, but they should be about the same level.
The same.
Somewhat, not exactly the same. Yeah, I'm going to go over that. Okay. Then came law of detachment and law of syllogism. So law of detachment is just one if-then statement in which the if occurs again, okay? If you wake up late, then you will be late to school, okay? And then you wake up late. So we assume you're going to be late to school. That's law of detachment. Syllogism has 2 if-then statements. If you wake up late, then you will be late to school. If you are late to school, then you get a tardy. So if you wake up late to school, you get a tardy. You are combining 2 if-then statements together, and that's law of syllogism. And then you had a conjecture, which is something based on, the conjecture is based on the pattern, okay? That's the other vocab term you had there. These are going to be like, can you make this conclusion? And if so, is it which law of logic is it? Which means law of detachment or law of syllogism, okay? So those are the kinds of questions that you'll come from 2.2. 2.3 was where the postulates came into play. So the plane point postulate said a plane contains at least 3 non-collinear points. So if you could picture it, because you had that on your quiz and you had it in the homework, okay? It would have been just a plane and then a plane drawn next to it with 3 non-collinear points. Then plane line postulate said if 2 points are in a plane, then the line that contains them is in the plane. So it's hard to see what's there because it's cut off. But in the first drawing, we had just 2 points. And then in the second drawing, we had the 2 points with a line through them. That would be the visual representation of that.
I get these.
Oh, good. Plane, thank you for sharing. Plane intersection postulate says if 2 planes intersect, then their intersection is a line. So we had 2 planes that literally intersected and their intersection was a line. 2-point postulate said through any 2 points, there's exactly 1 line. So we started with just 2 points and we went to a line that has those 2 points. Line point postulate says a line contains at least 2 points. So we started with a line and then we went to a line that has 2 points. Line intersection postulate shows 2 lines intersecting at exactly 1 point. And 3-point postulate through any 3 non-collinear points, there's exactly 1 plane. So we would have started with 3 non-collinear points and then we would have gone to those 3 non-collinear points lying on a plane.
Is that all of 2.4?
That was 2.3. Yeah.
Was that all of 2.3?
Those are all the postulates from 2.3. Yeah. Yeah. We talked about perpendicular lines in 2.3 too. Like if you had the diagram and you had a perpendicular, which is like what that second questions 9 through 15. No, 9 through 12 on the right-hand side there. Sure. Which ones? Individually?
Yeah.
So that's the first one. And that's the second one. You're welcome. Okay. And then, so that's where the quiz ended, okay? Which, again, I'll go back to questions on the quiz in just a second. 2.4 was all the properties of equality from algebra and distributive, symmetric, transitive, and substitution, okay? So we had addition, subtraction, multiplication, division, reflexive, symmetric, transitive, and substitution. Well, no, we didn't have transitive yet. We had substitution. Those are, again, all on the Quizlet. The Quizlet covers the entire chapter. But this is where you're going to get something like this, which says solve the equation and justify your steps. So there's practice for that on the bottom. And then 20 and 21, where you're just identifying the property, you will also get questions like that. 2.5 is where we started talking about how those same properties apply to segments and angles, and this is where we started our proofs. So we would know substitution is if we're taking a value and substituting it in or using more than one things to replace it with one. Reflexive is anything that equals itself. Symmetric, we switch the order, and transitive is an if and then statement. If 1 equals 2 and 2 equals 3, then 1 equals 3. So the proof on your test is kind of going to blend 2.5 and 2.6 together. It's got the information 2.5, but it might have some of the stuff that we covered in 2.6 as far as angles and stuff goes, okay? And again, it is partially filled in.
There's only going to be one proof?
There's an algebraic proof, and then there's a geometric proof.
So one of each.
One of each.
So what's the difference between an algebraic one?
You solve it.
2.6 is what we did yesterday, the congruent complements theorem, the congruent supplements theorem, the linear pair postulate, the vertical angles theorem, and the right angle congruence theorem. There was 5 things in yesterday between postulates and theorems, okay, that you have to make sure you know so you'd be able to apply it not only to a proof, but also to the diagrams, right? So like in the homework, the ones that you had vertical angles, you had to set equal to each other, or linear pair, where you had to add them together and set them equal to 180.
Are those really postulates and theorems that I have to remember?
In 5, I mean in 2.6, yeah. But then you have all the properties and stuff from the beginning of the chapter.
Oh, like the substitution.
Yep. And the definitions of like the converse, inverse, all the stuff. So all of that's on one Quizlet. It literally is at the bottom of the module. It's the whole thing. Say again? These are the only new ones. Yeah.
So the quiz is going to help us a lot.
Yes. So now look at your quiz.